Hello YouTube, this is Alexander again. Today is kind of a tinkering day. I have here on the bench a power supply coming from my brother. Actually, the main part is coming from my brother. He gave it to me, and I had to use it to build this power supply, which is specially proposed for amplifier application. And so, as you can see on the front panel, you can have several output, and you have here the main output about 12 volt supply to supply amplifier for car purpose or anything working on 12 volt supply. And also it has single rail 8 voltage. 8 voltage means you will have a voltage over 12 voltage, which is the minimal voltage here, because according to the fact that this power supply is coming from a very powerful computer, it has on it 3.3 volts and also 5 volt output, which are not required here. And so the main voltage, which is affordable here, is used with a booster. You can see here through this glass to have a variable output from the 12 volt. The decision I made to make this kind of device, which is not fashion actually, because lots of people don't like to use a booster to convert low voltage. It's because actually this power supply use to create 3.3 and 5 volt use a buck converter to create this voltage from the main voltage, which is here 12 volt. I will show you the internals of this power supply and explain to you how the engineers who's made this power supply made to give lower voltage. So in this front panel, you will have the main 12 volt output. You can see the outlet are very huge, because you can have here 60 amp available. Here you have the single output rail, which is a variable voltage output for single amplifier. And here you will have the symmetrical output. This symmetrical output is made with the voltage splitter I made in another video you can see on my channel, and this device is used on this one to create a symmetrical output for amplifier who need this kind of power supply. The main thing with this power supply is not to supply constantly an amplifier. The purpose of this device is to make some tests, some power bench actually, and also you can make some experimenting. This device is not made to supply, it's just a bench power supply for laboratories. It's missing a fan on it because there is a big lack of room on it. So you can see here through the glass, you can see here the booster, which is required to to create 8 voltage coming from the 12 volts. And you will have here a twin display which displays here voltage and amps coming from this unit. Also, you can choose the voltage you want, if you want the voltage according the low voltage output or the high voltage output here. Also, the voltage indicated here gives you the information sorry, about the symmetrical power supply. You need to multiply this value by 2 to have the voltage according the supply, the symmetrical supply here. After a while, I decided to make a dedicated voltmeter here, which is here. So from the start, I was just using this one. But to maintain this voltage according to the symmetrical output and to maintain also this indication, I preferred very lately actually to make a little GNOS multimeter to have a confirmation about the voltage disponible available on this output. You will have this switch here, which is used to switch on or switch off this symmetrical power supply. Also, it's powering voltage splitter, and when you supply the voltage splitter, it's switch on this symmetrical power supply. This switch is made to toggle between the voltage here and the voltage here. Simply that. And also this button is used here to restart the unit after protection. The supply automatically switch off. You have to push the button to restart your device. Actually, this device is very reliable and it's working very nice, despite all the module I put inside. Or not inside, because it's an added module. So to make this stuff, I used here some tube, this kind of aluminum tube you can find on any market about to do-it-yourself stuff. And you need to cut it with a tube cutter like this. And also you need some screw to maintain this glass correctly on this side of the unit. And I don't know if you can see it, but this boost converter is maintained by a little threaded rods here, and the glue you can see here is only to maintain principally these capacitors which are working here with the voltage splitter. So I'm going to show you the internals and see what I made here. As you can see, this is a very powerful power supply, about 750 watts from a very powerful power supply. Very powerful computers. I decided to use this shape because it's more easy to stand on a bench, which is not the case of this one. This power supply comes from a server, and as you can see, it's possible to work with this, but actually I don't like the shape of those one because it's long and flat, and it's not actually the best way for my purpose. I prefer this kind of shape, here, because it's very easy to tidy up on the bench, and this way, this front panel gives you a very ergonomic way for working with. So you can see here the voltage splitter, which I made in a previous video. As you can see here the coil which drives the MOSFET here, and the diodes to make this symmetrical output. Here you will see the shunt. This is the big shunt used to have an amperage indication on the display. And this is here just capacitors for the monorail output, and here you can see the capacitors need to work with the voltage splitter to create the symmetrical voltage here. So as you can see, there is here several wires, and you can see here the main wire, which is very thick actually, to give the plus 12 volts to this outlet. And here you can see the negative, but in this configuration the negative is not connected directly to the ground. It's connected first to the shunt, and the shunt is connected to the ground. In this configuration it works like that, especially with this ammeter coming from China. This is the configuration need to work with. So also you will have some wire for to give some voltage on the booster, which is here. You can see the power supply of the booster, which is coming from the main board actually, from the same connection you can see here. Those yellow wire are the 12 volts, exactly like this red wire, but those ones are to supply the booster. Also, the negative wire of the booster is going through first before to connect to the ground, is connected to the shunt, which is itself connected to the ground, because it's a special configuration coming from devices coming from China. They don't really work like we used to intend about ammeter, etc. This is the Chinese configuration. We need to connect it like this for working. So I didn't make any modification about the supply, because actually this kind of supply use a lot of current when starting. In this one I found it's acceptable for the moment. I don't know if I will make any modification to create a slow charge. Those connections, which are just the green wire coming from the start of the supply. This is very simple actually, not very not sophisticated at all, and so it's that's all, nothing more. And actually I'm going to remount this stuff and to switch on. In this power supply you will have this main transformer, which is able to create the 12 volts with several amps. And as you can see here, this heatsink, not this heatsink, sorry, this one, this heatsink and those capacitors and those coil, I don't know if you can see the coil just here. Those coils are used by this supply to create the low voltage. We can understand it's talking here about the 5 volt and 3.3 volts, which are required in mainly computers to work with this kind of voltage, of course. And this voltage, this low voltage, are not coming from this main transformer, but are created by the 12 volts using this buck converter. This is the first time for me I see this kind of configuration. It was very marveling actually, because I didn't know some engineers decided to make buck converter to make it more easy to realize. So it was working very nice on the computer which was used this power supply. So okay, the flow chart here is very easy actually. You can see the power supply and the switch of the power supply, the main here. You can see here the ammeter, the green wire, which is connected to a reset button. It's very simple actually. You will have the 12 volt 60 amp connected directly to the yellow. Here a very thick wire in red was used, because it was what I had actually. This here is a Chinese voltmeter connected connected to the output and the ground, and it's showing it confirmation about the 12 volt output. Here I draw here a booster which is increasing the voltage, and the booster is connected directly to the 12 volt output after the shunt, of course, to give an information about its consumption. And so you will have here the single rail high voltage output, and the single rail is feeding the voltage splitter, which is able to give symmetrical voltage output, and you will have the positive output, the ground, which is not a real ground. This is a floating ground. It's not the same ground on the power supply. And you will have the negative output. Also, you can see here diodes connected to the output to confirm that there is actually a voltage on it. So the main display on the top of the billboard here is the volt and the amp meter, and you can choose the voltage display between the 12 volt and the single rail high voltage output. And by switching here this switch, you can display also the single rail high voltage output, and also the voltage on the rail, symmetrical rail, which you need, of course, to multiply it by 2, because you will have a negative and positive. For the instance, if you put 40 volts on the single rail, you will have 40 volt positive and 40 volt negative. I make this because I thought it was not very useful to make a display for the negative and again a display for the positive. A single display is enough, I think, for me. So it's a very easy flow chart actually, and that's all. To make this device, I used this power supply, which is protected actually. I'm not going to put this on this because it's okay, the project is finished, and I'm going to use this outlet. You can see here, and okay, because the project is nicely resulted, so I'm not going to use this one to make this stuff working. Of course, need to switch on. Okay, all is working here. Of course, the symmetrical output is switch on, so I'm going to switch off for the show. What you see here is the 12 volt output on this big outlet, of course, and also you will have 12 volt here because the selector is connected, is toggled on the big outlet output. But if I switch on this toggle switch, it would show you the voltage on those outlet here, which is a high voltage variable high voltage output. And to make you see how to change, you need a screwdriver like this, and you can see a little hole here, this hole on this panel, because I make this because it's very easy to do actually. Instead to make some potentiometer connected to the PCB of the boost converter, I didn't want to do this, so with a very thin screwdriver like this, you can change the voltage output as you need, of course, and you will have, when you're tweaking your voltage output gently like this, you will have this voltage in a single rail, the negative here and the positive on those outlets here. This is in case you need it for a mono single rail amplifier, which is not the case of this one. Those kind of amplifier, which are very nice actually. I made a video like about those kind of stuff on my channel if you are interested with. Those kind of amplifier are not expensive, but requires a symmetrical power supply, and symmetrical power supply are very expensive. are not so much expensive, but are really more expensive than boost converters. Actually, a boost converter can be used for those kind of amplifier, but it requires a voltage splitter. Voltage splitter makes a twin voltage, a negative and positive, with a monorail voltage, which is the case here. So if I want to connect this very nice amplifier, about 450 watts RMS, we need plus 65 and minus positive and negative 65 volts. So plus and minus, and I need to connect this amplifier here. As you can see, if I want to use this output, which is not constantly on, I need to switch on this supply, because firstly, when you want to use this kind of device, you can use only a single rail output, which is not the same thing, but you can use also in the same time the symmetrical power supply. The symmetrical power supply is available when you have the LED output, white LED output glowing here, like this. Those LEDs are showing to you then you have a voltage, and this voltage here is this voltage multiplied by 2. Also, you will have 35 volt positive and 35 volt negative, which I am going to show you now. You can see here 35, nearly 35. And if I don't touch the black probe, I just change the red probe, you will have now a negative output, which is exactly the same voltage than the positive, but inverted. And also, if you want to multiply your voltage by 2, of course, you can take the opposite outlet, and you will have here 70 volt symmetrical output. But you can use it like a single output, but it's not made for that, but you can use it like this. And of course, you will have this 35 volt on this main output here. And of course, here you will have the 12 volt 60 amp available for any amplifier for audio, for car, etc. Any devices working with 12 volts supply. Okay, I'm going to show you the voltage you can reach with this little screwdriver. You can see here a very high voltage. You can see the voltage rising. Of course, you can see a little amp because the boost converter needs to charge the capacitors. Every now and then it needs a little power to charge the capacitors actually. So here we have 100 volts here, and negative 100 volts. And if we are interested to measure the voltage output, you can see, according to the display you will have here, you can have nearly 100 volts. And of course, if I use the external output, you will see you will have nearly 200 volts DC, because this is a symmetrical power supply. So here you will have a bulb. This is a 24 volt bulb, not 12 volt. This is not what you use to find on many cars. This is a special bulb coming from a factory, and we are going to see how it's work on 12 volt output, as you can see here. And you can see it's glowing, and you can see the consumption is about 2.8 amp, and the voltage you can see here is about 30 volts, which is the voltage after the boost converter. So if I want to connect my bulb to this voltage, which I can adjust with this little screwdriver. Okay, like this. Okay, if I want to have a little more brightness, I can connect it like this. I have a little more brightness, but this is always 12 volt, and this bulb is working with 24 volt. If I want 24 volt, I can use this single output, but also I can use the voltage output coming from the voltage splitter, which gives to me the twice the voltage actually. So let's see the consumption, and let's see how it works with the voltage splitter. You can see the bright is very strong, and you can see the rising of the voltage, because actually on this output this is twice the value of this one, which is nearly the voltage working, the voltage required for this bulb to work, for working. Actually, I had the choice between those two models, and I prefer to use this one because it has more fuse, and it's more strong than this one, which is able to disrupt actually, because this is what happened on other experimenting, and I really prefer to use this one. And for this one, if the current draw is very important, it's able to draw a lot of current, which is able to shut down this power supply. What I'm going to show you now is the protect effects of this power supply, and we are going to see how it reacts if I made a short, and see how it reacts. So I have here just a single voltage used, which is just for the experimenting. I make here a short circuit on the output, and you can see the device switch off. To restart the device, and you can see the fan is stopping turning. You can see the fan is not working anymore. If I want to restart the device, I don't need to disconnect the switch on the back. I just have to push this button. Of course, it's not easy for it to restart. Sometimes you need just to push twice the button, and you will have here your the voltage again. And of course, if you want to use twice the voltage, you will have more power. If I increase the voltage again, I can destroy this bulb, but I don't want really to do this. Okay, this is the minimum voltage output, and you can see here the minimal voltage output. This is the 12 volt. So this buck converter is able to go a little bit under the voltage of his power supply. Of course, this power supply is made in purpose to use a symmetrical power supply on any amplifier you want, to make some experiment and to check the power supply you need for this. And also you can use it for very high voltage, because you can add the symmetrical negative and positive voltage. You can add them to have a very high voltage if you need it in some application. Also, you will have the 12 volt 60 amp here for any application about car amp or car devices working with the 12 volt. You will have your single rail. It can be used on certain amplifier. You can find Class D amplifier working with a mono rail like those one, which requires just a mono rail. And of course, when you can use a simple boost converter to supply a monorail Class D amplifier, the Class D amplifier is very expensive. There's this kind of amplifier which, when you are talking about more 100 RMS watts, which are very high fidelity Class D, they are quite expensive. They are not so cheap like you can find to make some some kits, Bluetooth kits, etc. They are really more expensive because they are really more powerful. But in this, for this model is not single rail voltage, it's symmetrical voltage, but it's very cheap. Actually, this one works very nice, but just I guess I didn't make the experiment for the moment, but I guess that you need to put on this amplifier a larger heatsink to use it properly, and of course you absolutely need a symmetrical power supply to use this one. You cannot use a boost converter, which is not very expensive, but if you make a voltage splitter, you can use a boost converter to supply this power supply. Okay, this is the end of the video. I hope you like it. It was a kind of tinkering day today, and tell you see you soon.